It is just another busy work day, with all the usual hustle and congestion. With all the close calls and near misses that people all over the world have come to accept as the normal level of risk in everyday life. But on June 5, 2020, high overhead and behind the sun, what no one saw coming, what no telescope on Earth was able to see against the blinding light, was an asteroid big enough to destroy an entire city. From behind the sun, Asteroid 2020 LD came hurtling towards Earth, faster than a speeding bullet. It shot past less than 4/5 of the distance to the Moon, and nobody saw it. Until 2 days later, when the rock emerged from Earth's shadow into the night sky going away. The planet is 66 million years overdue for an asteroid attack, similar to the one that wiped off the dinosaurs. Relying solely on luck for survival, the apocalypse never seems far away. The asteroid was quickly identified as a near-Earth object with a diameter of about 140 meters. A near-Earth object is an asteroid or comet that passes close to the Earth's orbit. So, if an asteroid manages to pass by Earth inside this 45 million kilometer radius, it is referred to as a near-Earth object, or a near-Earth asteroid. Asteroid 2020 LD passed within 307,000 kilometers, at a speed of around 27 kilometers per second. Should the asteroid strike the planet, it would easily wipe out an entire city with its mass and velocity. In order to put the 2020 asteroid into perspective, the asteroid that struck some 50,000 years ago near Flagstaff, Arizona, was about 46 meters and had hit at a speed of 15 kilometers per second, far less than the 2020 asteroid. Compared with the recent Chelyabinsk incident that happened in Russia on February 15, 2013, which caused 1,300 people to seek emergency medical help, the level of damage appears to be much more alarming. After all, it was the biggest asteroid to fly by Earth since 2011. Another 100-meter asteroid approached Earth in 2019, the year before the 2020 LD asteroid, at a distance of just 73,000 kilometers. The asteroid, dubbed City Killer, identified as 2019 OK, also came from the same direction as the Sun. And once again, it wasn't discovered until the very last minute. Even though we are getting better at detecting stuff billions of light years away, detecting asteroids in close proximity to the Earth still appears to be a daunting task. As of today, only 5 asteroids have been discovered before impacting into Earth. The first cause of this arduous task that springs to mind is that asteroids are much smaller than stars or planets. But it's not just a matter of size. In 2017, we even failed to identify the 200-meter interstellar visitor Oumuamua. Of course, there ought to be a lot more to it. To find an asteroid, astronomers collect multiple photos of the sky over several days and then run them through a computer algorithm that searches for moving objects. The speed and brightness of an object allow scientists to begin tracing its orbital route. However, it's a hard row to hoe. First of all, asteroids barely reflect any light. Therefore, there is very little possibility of finding any asteroid that approaches from the direction of the Sun. Second, most asteroids are detected using ground-based telescopes, which are limited by climatic conditions. If an asteroid decides to pose a threat on a cloudy day, we are probably out of luck. But why not use space observatories instead? After all, they offer some of the most detailed photographs of space and are much more advanced. Technically speaking, orbital telescopes are designed for deep space imaging only and cannot discern objects so close. With current state of technology, NASA scientists can estimate the orbit's direction with a bit of certainty for the next 100 years. I use the word bit because asteroid trajectories are extremely erratic. The path that an asteroid will take is the superposition of forces induced by the Sun, the planets, and also their own initial orbital velocity. This means that even a small error in trajectory can cause major inaccuracies for which humanity may have to pay a hefty price. As a result, anyone who wishes to foresee asteroid trajectories must do it right up until the last moment. Hunts for asteroids have just recently started. The first ever asteroid to be discovered was by Giuseppe Piazzi in 1801. He detected a small object moving between the orbits of Mars and Jupiter. Piazzi named the 1,000-kilometer-wide asteroid as Ceres, which was later classified as a dwarf planet as we know it today. Since then, we have discovered dozens of millions of asteroids. These asteroids, which are located primarily between Mars and Jupiter's orbits, create a band known as the asteroid belt. While most asteroids attempt to remain near one another, thanks to gravity, some do manage to elude the belt and drift in an arbitrary path. Tragically, some do also end up in close orbits around the Earth. And these are the asteroids about which we should be concerned. As of today, 27,440 NRAOs have been discovered, of which 117 are comets and 27,323 are asteroids. Out of these 27,323 asteroids, 2,270 are considered as potentially hazardous asteroids or PHAs. A potentially hazardous asteroid is defined as an object capable to make close approaches to the Earth and is large enough to cause significant regional damage in the event of an impact. 150 out of these are estimated to be larger than 1 kilometer in diameter. Is it possible that an asteroid of this scale will strike Earth and wipe out the entire human race? To answer this, we must first examine how frequently asteroids have struck our planet in the past. By looking towards the Moon, we can physically count the craters by looking toward its surface. But this isn't really the case with Earth. Perfectly preserved craters are either extremely rare or have blended in exceptionally well with their surroundings. The truth is that the Earth has probably been struck by asteroids and meteorites exactly as frequently as the Moon. In fact, tiny asteroids are continually bombarding Earth even right now. The mass of the Earth is actually increased by around 15,000 tons each year by space rocks as a result of this. But micro-asteroids are not what we are looking for when it comes to mitigating large-scale global catastrophes. The Torino scale was developed by astronomers to more comprehensively study the impact risk posed by asteroids. The integer scale used by the Torino scale ranges from 0 to 10. A 0 denotes that an object is either too tiny to enter Earth's atmosphere intact, or has a negligibly low probability of colliding with the planet. A 10 indicates that a collision is unavoidable, and that the impacting object is massive enough to precipitate a worldwide catastrophe, as in the case of the Chicxulub event, which nearly wiped out the dinosaurs. Speaking of the Chicxulub event, which took place 66 million years ago in what is now Mexico, it was most likely by far the worst cosmic catastrophe to ever affect Earth, coming in second only to the hypothetical collision of planet Theia with Earth that led to the formation of our Moon. Land vegetations destroyed, ecosystems perished, and most significantly the extinction of dinosaurs and more than 75% of all land and sea animals. The dust and aerosols that were launched into space following the collision brought about a cosmic winter that forced life to seek shelter farther from the ocean's surface. But the largest asteroid known to have ever hit during the recorded history was probably the Tunguska event, a whopping 8 on the Torino scale. In the extraordinarily isolated forests of Siberia, which were then part of the Russian Empire, a massive rock on June 1908 entered the Earth's atmosphere from above and was on a direct collision course with this location right here, near the Tunguska River. The 90-meter-wide meteor was traveling at a blistering speed of about 27 kilometers per second. The asteroid exploded just a few kilometers above the remote wilderness of Siberia. The power of the explosion was somewhere between 3 and 5 megatons, comparable to a modern-day hydrogen bomb. Due to Siberia's extreme remoteness, especially in 1908, it is unknown if anyone actually died in this explosion, though it is estimated that 18 million trees were destroyed over an area roughly the size of Rhode Island. But the shockwave reportedly did shatter windows and knocked people over hundreds of kilometers away. This kind of event is thought to occur only once every 1,200 years on average. 1-kilometer-sized asteroids appear to strike our planet every 444,000 years. Larger asteroids with a diameter of 5 kilometers hit every 20 million years or so. Finally, truly titanic asteroids over 10 kilometers in size that are capable of ending life on the planet strike the Earth once in about 66 million years. In 1998, Congress directed NASA to locate at least 90% of the asteroids and comets that are very close to Earth and may approach the Earth's orbit. Those asteroids which hit Earth every 500,000 years and could endanger life as we know it on Earth. According to the findings, we now have some candidates that can contest a call for an end to life on Earth. The first is the asteroid BENNU, which recently gained fame when the NASA spacecraft OSIRIS arrived there to collect samples from the asteroid. In 2020, the spacecraft left BENNU, and it is anticipated that it would return the samples to Earth in early 2023 for more research. Talking about the asteroid, BENNU is a 270 meters broad space rock, roughly the size of the Eiffel Tower. It is presently moving at a speed of nearly 28 kilometers per second in the Leo constellation. An entire large country would vanish from the face of the world if BENNU were to strike the Earth. BENNU has a 1 in 1,750 chance of colliding with Earth in the next 3 centuries, according to scientific research. Nearly all of the riskiest encounters with BENNU will occur in the late 2100s and early 2200s, with the single likeliest impact coming on the afternoon of September 24, 2182. On that Tuesday, BENNU has about a 1 in 2,700 chance of hitting Earth. The most likely scenario is that the asteroid would just pass very close to the Earth. But once more, these are only computer calculations. The course of an asteroid is actually determined by literally hundreds or even thousands of different factors. For example, the asteroid's rotation, the possibility that it might be struck by another asteroid, or the momentum provided by solar ray particles. It's more than just a high school trigonometry problem. The second asteroid on the list is the infamous APOPHIS. This one is quite interesting. Here's how it goes. According to the Egyptian legend, APOPHIS is an evil snake god who tries to consume the sun every night. The 350-meter broad, 20-million-ton asteroid, which is roughly the size of 3.5 American football fields, will brush through Earth on April 13, 2029, which by the way also happens to be Friday the 13th. It will come so close to the Earth that it will be visible in the sky from some locations. It's intriguing that early forecasts placed the likelihood of an impact at about 2.7%, or roughly 3 in 100. APOPHIS smashed all previous records by receiving the highest Torino scale score of 4 ever since the scale was created. Although later studies ruled out the possibility of an asteroid impact, APOPHIS will still pass Earth closer than several communication satellites flying at about 31,500 kilometers. It will be the nearest asteroid of its size in recorded history. APOPHIS will reach a brightness of magnitude 3.1 on that day. So long as you reside in the southern hemisphere, you can see it with your naked eye, and it will look like a speck of light moving across Australia during this close encounter. This close encounter at its closest approach to Earth will be above the Atlantic Ocean and will travel so quickly that it will cross the Atlantic in less than an hour and will traverse the United States in the late afternoon or early evening the following hour. Earth's gravity will cause APOPHIS' orbit to widen, and it is expected to make another flyby in 2068. The chances of it colliding with Earth at that time were initially estimated to be 1 in 150,000, but new observations indicate that those models need to be updated. As of the making of this video, APOPHIS has been removed from the Century Impact Risk Table, which is a list of objects that travel so close to Earth that astronomers have yet to rule out a possible collision. The last one is the 5 kilometers wide asteroid named Florence. Because Florence is so large, it has 2 moons of its own that orbit the parent asteroid. 5 years ago, on September 1, 2017, Florence passed the Earth at a distance of just 7 million kilometers. or 18 times the distance between the Earth and the Moon. A hair's breadth on the cosmic scale. The asteroid was visible through medium-sized telescopes as it traveled through the constellations. If it is ever forecasted to collide with us, we better cherish the final moments with our loved ones. The next flyby will be on 2 September 2057, predicted at 7 million kilometers. Physicists like the great Dr. Stephen Hawking said that an asteroid impact is the greatest threat to life on Earth. What then, as a species, can we do right now to protect ourselves in the event that these celestial behemoths decide to threaten us, say, tomorrow? Do space agencies around the world have any plans to combat the asteroid? Currently, we just have some limited options. The rapid demand and paucity of supplies would make such a large-scale evacuation all but impossible. And where would humans even go to? Spending trillions of dollars merely to starve on Mars or the Moon isn't the best plan. Only multimillionaires or the most powerful individuals in the globe at the time would have the chance to see this cosmic firework. And even they would probably perish if supplies were depleted. The truth is that with such little time, humanity is powerless. We do have some plans though, in the event that scientists happen to spot the asteroid early. In order to prevent an asteroid from striking Earth in such a scenario, NASA and other space organizations will have a number of options, and they have already put those options to the ultimate real-world test. The DART mission of NASA blasted off on November 24, 2021. The expedition spacecraft had traveled a great distance to the dimorphic asteroid Didymos on September 26, 2022, when it reached its destination. In an effort to alter the asteroid's speed and course, the spacecraft collided with the rock as it arrived at Didymos. According to NASA, they were successful in altering its course. NASA says this test tells a lot about what can and cannot be done to prevent a life-ending, planet-destroying asteroid from colliding with our planet's surface. Other Hollywood-style asteroid avoidance strategies include utilizing a gravity tractor, which would slowly but steadily change the route using its gravitational pull, or nuking the asteroid. A concentrated solar energy panel that would direct the sun's rays onto the rock, causing it to vaporize and generate propulsion, or black painting one side of an asteroid. These missions demonstrate how seriously NASA takes this issue. In an effort to determine whether their theories can actually save the planet, they are now finally putting their expertise and experience of some of the smartest brains to the test. But regardless of this, the fact is that there are millions of meteors and asteroids in space. It is basically a game of whack-a-mole. These tools will just act as a safety net in case something goes wrong. Although we don't know when an asteroid will strike, the consequence of it would be disastrous. To conclude this video, let us perform our own thought experiment of a 10 kilometers wide asteroid that has been categorized as an average of 8 on the Torino scale and is about to impact the Earth in the near future. First of all present asteroid avoidance missions become pointless, since humanity has never practiced for a catastrophe of this sort. The asteroid would slam into the Earth, leaving humanity with little to do except watch the countdown before the asteroid hits. Where the asteroid would strike would determine where the majority of the destruction would occur. An impact above London would instantly destroy everything in the United Kingdom, France, Ireland, Belgium, Switzerland, Germany, and Denmark. People inside this 100 kilometers wide crater would quickly vaporize due to temperatures equivalent to the sun's surface. The raging pit would be large enough to swallow the entire big island of Hawaii. Fortunately for us, only 3% of the planet's land is occupied right now. This means that if an asteroid strikes a densely populated city, it must be the worst day in human history. If you haven't looked for bunkers nearby, now is probably the time. Outside of this circle, people would need to immediately flee to their closest bunkers, each of which would need to have at least 6 months' worth of supplies to sustain them. Because the fire had destroyed the entire city's infrastructure, the internet would stop working. Those who are unable to find shelter will experience the brightest flash of light in human history, unaware that they would be annihilated in a matter of seconds. global tsunami waves will reach heights of up to 300 meters, or around the height of the Eiffel Tower. Massive wildfires in at least half of the world's forests would cause the extinction of most species, especially those that are already vulnerable. The Earth would be rumbled by an earthquake reaching a massive 9 on the Richter scale. It would be the strongest earthquake in the last 150 years. Because of this powerful earthquake, every building that was still standing will fall. But if you think that the worst disaster is over, wait for the worst to come. Due to the high-speed collision of the asteroid with the Earth, thousands if not millions of massive chunks of land and rocks from the Earth's surface would be catapulted into the atmosphere. While some of them would reach the escape velocity or the speed needed to completely break out from the gravitational influence of the Earth, many would return to the surface once more at incredible speeds, causing a second round of asteroid strikes. For the next 30 minutes or so, it would rain mountains. If your bunker appears to survive this overkill, you'd be quite lucky. Approximately 6 hours later, the rock rain would stop, making it possibly safe to exit the bunker and observe the devastation for yourself. For a second, everything would be unrecognizable. The entire planet has practically been turned upside down. Your favorite restaurants, hotels, and attractions, everything has vanished. Under these layers of ashes lies the entirety of human history. A thick layer of smoke and dust would quickly envelop the globe and blot out the sun, an impact winter that could last for months or even years. Sunrise and moonlight would become a thing of the past. Without the components necessary for photosynthesis, the majority of plants would probably die. Plant-eating animals would die out, and the animals eating those animals would also eventually die out. Probably, the only organisms remaining would be extremophiles. The name literally translates as extreme lover. Extreme organisms, such as tardigrades, have been observed thriving in even the harshest conditions. Volcanoes, icebergs, or complete vacuum, you name it. Tardigrades are capable of surviving multiple harsh conditions. They are practically indestructible. Tardigrades can curl up into a dry, dead ball, thanks to a unique adaptation. They can last for decades in this state in cold, dry settings like space. As for us, the humans, it would be a close call. Darkness, freezing cold, and global famine would throw the world into chaos. Our final hope for re-establishing society would be the little communities of people living in these underground bunkers. This would not be the end of the world, but it would probably seem like it. Even though asteroid collisions pose one of the biggest risks to the planet and life as we know it, scientists claim that there are currently a great number of issues facing mankind. The greatest threat to humanity today, according to many experts, is climate change. In fact, scientists and other professionals have been meeting to debate this issue for years. In a special report titled Global Warming of 1.5 degrees Celsius, the UN Intergovernmental Panel on Climate Change claims that human activity is already to blame for a 1 degree Celsius rise in global temperature. Since the pre-industrial era, humans will experience a greater rise in temperature if current patterns hold, which may bring on more severe storms, more intense heat waves, droughts, and flooding. Additionally, it may result in a rise in sea levels, which may cause coastal flooding and ultimately have an impact on the treatment of wastewater and drinking water. This will then contribute to the spread of waterborne illnesses. The disruption of the environment and considerable loss of biodiversity will be the most notable of all these changes' global cascading effects. Other dangers include, but are not limited to, artificial intelligence surpassing human intelligence, a biological warfare, global pandemic, or a nuclear conflict. Scientists think that anthropogenic risks are significantly more plausible than a doomsday attack from outer space. They believe that perhaps the apocalypse won't be dealt by a swift, decisive blow, but instead a gradual faltering decline. One disaster bleeding into the next, until the final embers of humankind silently fade away. Whatever the case, it won't take place soon. After all, we made it this far. Millions of years of evolution, countless disasters, and humanity is still standing. Space is undoubtedly one of the realms that inspires both terror and hope at the same time. Continuous efforts and studies by worldwide space organizations demonstrate how small we are on the cosmic scale, yet large enough to avoid such catastrophic disasters. It's truly a miracle how far we've come. While NASA is constantly looking for asteroids, it hasn't discovered any asteroid that is large enough to directly endanger Earth yet. There is still a lot of space to survey, and the big one may be on its way. We simply haven't discovered it yet. So when is the doomsday? Maybe we don't know. Perhaps we'll never know until a giant rock comes from behind the sun, hurtling towards the Earth, only this time hitting it to call for an end.